Hey everyone, this is Davy. Today we're in Ghent for the NGBE conference in Belgium, organized by Sam and Jürgen. Oh, did I show you the logo? Here it is. Then, for the conference, we're shooting a Teach Me Anything section where we invite speakers, attendees to teach us things they know in under 10 minutes. It's going to be amazing, so stay tuned.
Welcome to Hackflix. My name is Jeroen. I'm a full stack engineer at ARHS Digital.
Hello, my name is Saleh. I'm also a full stack developer at ARHS Digital, and we are going to talk about reactive architecture.
Okay, Jeroen and Saleh, thanks for coming. What are we talking about today?
We're talking today about reactive architecture and how we basically came to this reactive architecture from a non-reactive architecture.
Okay.
What do I mean by that? It's because we're working on a big application with a front end and with a lot of backends.
Okay.
And
I guess since we're in an Angular conference, the front end is an Angular.
Indeed,
Okay.
it is in Angular. Okay. And the front end and the backends, they communicate now in a non-reactive manner. What do I mean? They communicate in a synchronous way. And what we do now is to transform this synchronous way of handling communication between the front end and the back end to an asynchronous way or event-driven system.
How do you represent that for people watching right now? How do you represent?
Let's maybe start with how it is now, how we do it now. So for now, let's say we have our front-end module, our Angular application in the front end. Okay. And this application communicates with like a lot of microservices. We call it microservices because they are small backends, basically. So we have a full microservice architecture for the backends. And for now, they all communicate in a sync way. So for now, it is basically like this. We also have like, for some of the microservices, also communicate with a database, which was before in Oracle SQL. And yeah, that's basically the general overview of the architecture, how it was before.
So when you mean secure, but you also mean it goes one way, right? It just goes, there is a pull mechanism from the front end, right?
Yeah, indeed. So the front end does the calls proactively, let's say, not reactively. It just sends like a request to the microservice, and when let's say, the front end will wait till the microservice responds. Okay. When it responds, it will continue to do its work.
Okay, very good.
Maybe I can let Saleh also show how that works in detail.
Yeah. So basically, I'm going to explain this now in a timeline way. Okay. So the front end is basically on this side. Yeah. And
feel like it's just a normal pane.
Yeah.
Just use
it. Okay, perfectly. So here we have the back end. Yeah. Okay. And what is going on is that every time the front end wants to make a request, so basically a pull request, is making a call. And the thing is, the backend will take some time to process the request, and this will come back to the front end. But the thing is, in the meantime, since it's a sync call, the front end is waiting for the answer. So it's taking some time. And once the answer will come back, he will make again a second call. So in that way, the front end is always indeed pulling. So it's a lot of waiting time for the front end. And we want to improve on this part. I will let back basically Jeroen to explain the next step.
Yeah, let's maybe take a new page to like show you how we have the architecture now. So it's like this, all right? So let's maybe take the front end because we still have a front end. There's nothing that's not going to change. And let's say that we here have already our microservices. Let's say 3 of them for now. And now we basically have like 2 components extra, basically. One is a what we call a broker. This is basically an API that's exposed via GraphQL. So we will maybe say GraphQL, which is basically an API. So this is an API that's being called by the, let's say, for the front end. And this GraphQL is in contact with a database, which is now not anymore Oracle, but it's now Couchbase.
Okay.
And besides the GraphQL API being connected with a database, it's also basically together connected with what we are an event bus, let's say, that's being handled by Kafka.
Okay, very good.
So how does this work basically? I will maybe do directly the call to here, because to explain the system it's easier to just have the event bus system there.
Okay.
So let's just remove this for now. When we have this Kafka bus system, basically we now have the front end who from one side can publish on this event bus system, which means it can push events, or in the previous term would be pull requests to the system. And it can also listen or subscribe to events coming from other microservices, coming from the other side, in two ways, from the other side on the bus system. So in the other sense, it's also the same on the microservice side. So the microservice will also be publishing and subscribing on this same event bus system. So basically now all the communication is being handled in the event system, and what the front end and the microservices do, or the backends do, is basically listen to what can come from this bus and publish topics as well on it.
So what do you think are the advantages of doing this? How are you improving the way the project, the system is built today?
Well, it will improve foremost the waiting time from the front end. I will let Saleh explain more about that, since he already explained before.
So to come back to basically timeline, so just to make it a bit simple, we have two microservices and the front end. So I will design again the front end on the timeline in the middle. I will put the first backend on the right side, and I will put the second one on the left one. Okay. And the difference is now that the front end can make a first call to the first backend, and immediately he can also make a second call to the second backend. And basically both will take the time that they need. And in fact, the front end is not waiting, because if he wants, he can even call a third backend if he wants. In the meantime, once the processing time is done on the backend, the response will come back to the front end. In that area, the improvement is first that we are able to do parallel calls. The second one is that since we are going via the gateway, all the calls that are done in the with the microservices, the overhead is at the backend side. So it's in the internal architecture, and normally in that area the performance is better because the microservices are closer to each other. So we don't have this overhead time that is lost.
Okay, is there a scenario where the front end might be calling probably two microservices for the same data, and then one might resolve before the other, and then whenever the first arrived, the second one might arrive later, and then there is a race condition or something like that needs to be handled? Is there a scenario in that sense?
You want to answer?
So basically in that scenario, indeed you are right. So if you need some different data, you can have at the a kind of basically state inconsistency at the same time. To handle those kind of scenarios, there is a layer that is a bit more basically in depth, which is in fact you can manage your state basically via a state machine. So if you are
at which layer the state machine appears?
So in fact you have basically a backend state machine that is also basically listening on the Kafka events. So that I will just design it on this area with basically some kind of logic. So like a kind of graph, so you know the different state that you are doing. And in fact, you also have a small one in the front end, because imagine you might be, for example, disconnected from the network, and you can also enter indeed in inconsistent states.
Okay.
So to handle that, you have a front end and a back end finite state machines that should be small and quite direct.
Okay.
Their aim is not to be complex; it's just to see indeed if you are waiting for something for a long time. Maybe you want to go further or you want to retry. Okay, so this kind of logic will be held in such layers.
So we have 40 seconds left. Would you recommend people to go for this architecture or this way of working most of the time, or are there scenarios where that doesn't fit in 30 seconds?
It depends how complex you want it.
Okay.
If it are complex situations and you need to handle communication between a lot of backends and a lot of microservices, it's better to have a reactive architecture, because you don't need to care about the synchronous parts basically, or like the logic. You just need to send the events and wait for the events to come back. You don't need to know about the rest. If it's a small application, not necessary.
Yeah, very good. Thank you guys. Thanks for coming on the Hackflix Teach Me Anything, and hopefully people learn from it, and they came back, they get back to you and ask for more.
Yeah,
Thanks again.
Thank you very much.
Yeah.